Hi, this is Dave, and today we're going to learn about hashing. Hashing. Sometimes also we might call this, we're learning about a data structure called hash tables. So, let's get started. First, I need a problem, and the problem I have in mind is I would like to keep track of all my friends. And I have lots of friends, so I need a data structure to keep track of them. So, let's take a look at some of those friends. There's Sal over there, and Sal has some attributes. Sal has a name. His name is Sal, and he has lots of other things. Let's say he has a social security number, and Sal wouldn't like me sharing this, but his social security number is 1, 2, 3, 4, 5, 6, 7, 8, 9. Wonder if there really is someone out there with that social security number. Anyway, maybe he has a whole bunch of other attributes. There we go, ... And I have some other friends too, and here's one, and here's one, and let's give them a little bit more data too. We'll say this is Tom, and Tom's social security number is a little bit more random, depending on which keys I land on, and then maybe Jim, and his social security number is 222, like that. Okay. And since I'm trying to keep all of these in a data structure, I'm decided I don't need them in any particular order, so the structure I've picked out is a list. Is a set. Remember, a set does not have any particular order and is not allowed any duplicates, and that makes sense because I shouldn't have any duplicate friends. So there's my set. I'm trying to draw that as if it's a big bag of people. I like to visualize a set as a bag. So picture that's like a big sack, and there's these three people in it. Okay, now the operations that I want to be able to support is I want to be able to ask, given a friend, let's say, given a friend, here, I'll be even better, given a person, because some persons I might be able to want to query if they're in my set, but they're not a friend of mine because they're not in my set of friends. Given a person, does my set contain that person? That's one of my operations. Another one is, given a person, add them to the set. And finally, given a person, remove them from the set. And of course, I probably want all sorts of other operations too, like how many elements are in my set, and is the set empty, which I suppose you could accomplish with how many elements are in it, maybe some means of iterating over the elements. But let's just focus on making these three methods efficient. How can I make figuring out, does a person who exists in my set, add them to a set, and remove them from my set, and how can I do that efficiently? And I'm going to go for broke here. I'm going to go for efficient, meaning constant time. Constant time. Big O of 1. The time does not depend on the number of elements in my set. Can I make a data structure where I can make all of these operations work in such a way that the time does not depend on the fact that I have 3 elements or 30 elements or what have you? And if I think about the data structures I probably know already, the one that should come to mind as being efficient in this way, where most operations are constant time, is arrays. So we're going to start with an array. So let's draw an array. Let's push these guys out of the way. We'll come back to them. We'll draw an array. And I'm going to go for broke here. I'm going to make a really big array. Really big. This array is humongous. Let's see, how big is it? It's so big that the indexes are going to be so big I'm going to need some room for them. So here we go. This is element 0, 1, 2. And it's so big that this bottom one over here is 999999999. It doesn't even fit. You can kind of, there we go. Element number 9999999. And that's this one in this last box over here. This is element 0 up here. This is element 1, element 2, and then there's so many elements we get down to that one. So if I actually wanted to code this, I would write something like, I would like to make a new array of students. Let's say I'm using Java syntax, and let's see, that's 9 nines, so that's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1 billion students. So huge array, really, really big array. And the question is, how can I take advantage of the fact that this is really a big array and store my elements in such a way that I can find them really quickly? So the obvious thing probably is to say, well, I'll put the first student over here in box 0, and the second student in box 1, and the third student in box 2. But the problem with that, as we've probably encountered before, is if I want to determine, let's say this is Sal in box 2, if I want to determine, does this set, represented as this really big array, does it contain Sal? The only way I'm going to be able to find Sal is by starting in box 0, and then box 1, and then box 2, and it's going to take me a while to find him, and specifically it's going to depend on how many elements. So we're going to say it's order n, it's linear, the time is linear in the number of elements, and I don't want that. So I'm going to be more clever about where I store Sal. So here's the trick. I know that Sal has a social security number, and I know that social security numbers are unique. So I'm going to use that as the place to store Sal. 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I put Sal in my table, let's see, I think 1, 2, 3, 4, 5, 6, 7, 8, 9 is probably about here. There we go. And so there's a box over there. That's this box over here. And in that box, we're going to have reference to that object, Sal. So here's Sal. This time I think we'll give him some limbs. There we go. There's Sal in the box. And as before, he has a name and he has a social security number, which thankfully I've memorized for you. And it looked like that. I believe it had hyphens, but we can work without the hyphens for a moment. All right. So now the question is, did I achieve my goal? Can I really determine if my set contains that person object in constant time? So let's go see. My person object is this Sal over here. So if I want to determine if my set contains him, I ask that person object for its social security number. I can certainly do that in constant time. I jump to that box of my array, and I can certainly do that in constant time, and I check and I see, is it occupied? And if it is, it's got to be Sal, because Sal's the only one with that social security number. So have I achieved constant time for checking if a person's there? Yeah, I have. How about adding a person to my set? Well, if I want to add Jim, let's say, I look up Jim and I look up his social security number. I can ask him his social security number in constant time. I go to box, let's see, 425358789. Let's hope that's over here so it's still on the screen. 425358789. I go to that box, and in that box I store, let's make him a different color, how about blue? I store a reference to my friend Jim, who apparently doesn't have any limbs because I'm getting tired of drawing him. 425358789, but he does get hyphens because he doesn't have limbs, I guess. And there's Jim in the box. And how long did it take me to add him? Well, constant time. It didn't depend on how many elements were in my set. I jumped right to that box and I put him there. Now, if I went to add Jim again, now remember, I'm not allowed duplicates, so if I go to add Jim again, I would jump right to that box, see that Jim is already there, and do nothing. And I can also do that in constant time. So yes, I can add a person to the set in constant time. Finally, can I remove a person from the set in constant time? Well, if I want to remove, let's say, Jim, I'm going to ask that Jim object for its social security number. I can do that in constant time. I jump to that box number, 425358789. And in that box, I find Jim, and I go ahead and try to remove him, probably just by making this a null, and Jim will go away. So sure enough, yes, I can remove in constant time, so it looks like the really big array is letting me implement these methods in constant time. Now, what are the drawbacks of using a really big array? Because it would be very surprising if it turned out really big array was the absolute best way to store all this data. Because think about it, I have 3 friends. That means I have a billion element array with 3 occupied boxes. That seems pretty inefficient. So even though I have really efficient running times, I'm clearly headed towards some pretty miserable times in space usage. I'm using up a huge amount of space for my 3 friends. So unless I have approximately a billion friends, this is seeming like a pretty ridiculous way to store them. So what are the disadvantages? Well, it's really big. That's a clear drawback for my really big array. It's a big memory hog. Yeah, we already said that. I also noticed I needed unique ID numbers for this to work. If I don't have unique IDs, how am I going to be able to, given an object, figure out where to store it? And also, if I want to loop over my data, and this maybe is not as critical to me for the operations I was aiming for, but if I want to loop over this data, it's going to take me a long time to find all the elements. I'm going to have to loop through all billion boxes just to find my 3 friends. So that seems inefficient. So I definitely have some clear drawbacks to this approach. In the next video, we'll consider, is there a way that I can take this idea but not maybe occupy a billion elements? Maybe we can make a smaller array achieve the same beautiful constant running times. I'll see you in the next video.